Assalamualaikum and a very good morning everyone. So welcome to lecture 9. So today you're going to learn about the hydroxyl compound, also known as alcohol compound, which contain hydroxyl group. So for today, you will be introduced about the alcohol and how to naming the compound, the physical properties, and then learn about the preparation of alcohol from certain reaction and also the reaction of alcohol. So at the end of this chapter, students should be able, first of course, to differentiate the alcohol compound, especially the classification of alcohol, and then naming the compound from the molecular structure, explain the physical properties of hydroxyl compound, and also explain the reaction of alcohol. Okay, we start with the introduction of alcohol. What is alcohol? Alcohol is an organic compound with a hydroxyl functional group. The general formula for alcohol is ROH, where R is alkyl group. And then alcohol is very common in nature. For example, ethyl alcohol, which is also known as ethanol, is an active ingredient in alcoholic beverage. The first two members of homogeneous series, which is methanol and ethanol, is a very basic alcohol compounds. These are the application of alcohol compounds in agriculture, where you can find the alcohol is used in the bioethanol production and also being used for the disinfection of tools using the alcohol-based sanitizer, and then become the plant growth regulator. Alright, and the other one is the solvent extraction, when you want to extract a compound from plants or any fruits. Alcohols are classified based on the number of carbons attached to the carbon that bearing the hydroxyl group. Classification of alcohol can be divided into three types, which is the primary alcohol, secondary alcohol, and tertiary alcohol. The primary alcohol is the compound where the hydroxyl group attached to the primary carbon, where this carbon is attached to one carbon. Meanwhile, secondary carbon is where the hydroxyl group attached to the secondary carbon, where this carbon bonded to two other carbons. And the last but not least, tertiary alcohol, where this compound or where the hydroxyl group attached to the tertiary carbon, where this carbon bonded to the three other carbons. This classification is very important because it determines how the alcohol reacts, especially in oxidation and dehydration reaction later. So these are the general formula for the primary alcohol, secondary alcohol, and tertiary alcohol. Now we move to the nomenclature of alcohol. To name alcohol using IUPAC rules, first of all, select the longest chain carbon containing the hydroxyl group, and then you need to replace the ending of A and E to OL. For example, butane, when it attached to the hydroxyl group, it become butanol. And then number the chain to give the lowest possible number to the carbon bearing the hydroxyl group. You can start either from right, left, or from top to bottom. So you can try and error. The next step is you need to identify and name any substituent following the numbering that you assign already. Last but not least, combine everything and into the final name. Remember, the hydroxyl group has priority in numbering, not the substituent group. If there more than one hydroxyl group, you need to use the prefix di, tri, tetra, and so on, and it's replaced immediately in the front of the suffix ol. For example, 2 hydroxyl group diol, 3 hydroxyl group triol, and so on. Alright. We look into the example to naming the compound. So if you can see the first compound, which is 1-propanol, how we name the propanol, 1-propanol. So the first of all, we need to identify the longest chain that contain OH. So we start from right, which is this one will be the number 1, carbon number 1, number 2, and number 3. So at carbon number 1, attach OH. So which means we need to find the direction which give the lowest number of OH. That's why I start from the right side. So after you identify the numbering, then you can name this compound as 1-propanol. So which means at carbon number 1, it attached with the hydroxyl group. Same as the second compound. We can name it since the OH attached to the second carbon, which in the middle of the straight chain. So which means you can either start from left or right. So since the OH attached to the second carbon, so then we can name it as 2-propanol, which is this compound contain 3 carbon of straight chain. For the third compound, so you can name it as 1-butanol. However, if you can see here, is it the right way to numbering the compound? Because if we start from the left side, OH attached at carbon number 4. However, if we start from the right side, OH attached at carbon number 1. So which means we need to start from the right side. That's why we name it as a 1-butanol. And then for the fourth compound, this one, we can name it as 2-butanol, and then we need to start from the right side, because if we numbering from the right side, hydroxyl group attached at the second carbon here. That's why we can name it as 2-butanol, 4 carbon, butane, and then attached to the OH. So then we change into butane to butanol. That's why we can name it as 2-butanol. And then for the next one, we can name this compound as 2-methyl 1-propanol. We start the numbering from the right side, and then at the second carbon, we have methyl group as substituent. So that's why we name it as 2-methyl as substituent, and then 1-propanol, which means OH attached at carbon number 1. The last example here. The last example, the OH. So first of all, we need to find the longest chain of carbon, either from left to right, from top to bottom. So if you can see from this numbering is a wrong method, because you still can get the longest chain of carbon if you start from here. So this is number 1, and then carbon number 2, and this is carbon number 3. So the longest chain of carbon is 3, brings to the parent name for this compound is propanol, and then OH attached at carbon number 2. That's why the parent name is 2-propanol. At carbon number 2 also attach the methyl group. So the full name for this compound is 2-methyl 2-propanol. So this is how to find the longest chain of carbon, and also to name the complete name when it present the substituent group. Another example, when if you can see the first compound here. So for this compound, you can numbering the compound to find the longest chain of carbon if you start from the right side. So this is carbon number 1, 2, 3, 4, 5, and 6. And then after you numbering, then locate the OH group which attached to which carbon, which is it attached to the second carbon. So then for 6 carbon, we can name it as hexanol, and OH attached at carbon 2. So the name for this compound is 2-hexanol. Okay, and then the second group or second compound, also you can name it, you can numbering it using starting from the right side. So this is the first compound, second, third, and fourth compound, and the parent name for this compound is 1-butanol because OH attached at the first carbon. Next, if you can see, there are the presence of methyl group as substituent which attached to the third carbon. So the complete name for this compound is 3-methyl and then 1-butanol. Okay, and then the third compound, what is the longest chain of carbon? The tips that I give to you before this is you need to try and error either from any direction, from the left, right, top, or bottom. So if you can see here, we can start to numbering from the bottom of the structure, 1, 2, 3, at the way 4 and 5. So this is the longest chain of carbon which contain 5 carbons, and then OH attached at the second carbon here. So the parent name for this compound is 2-pentanol because it has 5 carbons, and then the substituent that attached to this parent chain is this one, got 1 and 2 carbon, which means it indicates the ethyl group. So ethyl group attached at carbon number 3 for that, so that the complete name for this compound is 3-ethyl 2-pentanol, like that one. All right, the fourth carbon. So if you can see the fourth carbon, it contains 2 hydroxyl groups, so which means we need to use the diol prefix. Okay, diols. So the OH groups attached at the first carbon and the second carbon, and then the longest chain of this carbon is 4, 3 and 4 carbon, so which means butane. So you can name this compound as, so first of all, write down the butane, which is in represent 4 carbon, and then write down the numbering of hydroxyl group where it attached at carbon number 1 and carbon number 2, and then the last one you put diol, which is it represent 2 hydroxyl group. The last one, the example, this contain the cyclic ring. Okay, so hydroxyl in cyclic ring. So for this compound, the OH automatically will attach to the first carbon, and then you need to find the root that which will give the lowest number of substituents. So which means we will using the clockwise, number 1, number 2, and number 3. So which means this methyl group attached at carbon number 2. So you can name this compound as 2-methyl and then cyclo. Since there are 3 carbons, so cyclo propanol. Alright, so this is how to name the compound. And then for this one, you need to do the exercise later. I will ask the name for each compounds of alcohol. Move to the physical properties of alcohols. Alcohols exhibit hydrogen bonding due to the presence of hydroxyl groups. Okay, the OH bond considered as polar bond because oxygen is much more electronegativity than hydrogen. That's why any molecule which contain OH bond is a polar molecule. And if you can see from the structure of OH bonding, the hydrogen is partially positive, meanwhile the oxygen is partially negative. The forces, okay, these forces, which is the partially positive and negative, produce that can hold two molecules together. This intermolecular attraction are present in solution but not in the gas phase, thus elevating the boiling point of the solution. This also creates the intermolecular hydrogen bonding, which increase the boiling point as well. So if we talk about the boiling point of alcohols, alcohols have higher boiling points compared to alkanes of similar molecular weight. For example, if you compare ethanol, okay, and ethane, ethanol will have higher boiling point compared than ethane. Because of what? Ethanol consists of hydrogen bonding compared than ethane, which only consists the weak van der Waals forces. That's why ethanol is higher boiling point compared than ethane. Same as the similar structure with have a similar carbon. Okay. And then about the solubility of alcohol, small alcohols such methanol and ethanol are soluble in water. Because of what? Because they can form the hydrogen bonding with water. Okay, with water. Meanwhile, the long chain of alcohol is insoluble in water due to the stretching of carbon, which non-polar part in the structure. Okay, because of the non-polar part in the structure, that's why it insoluble in water. And then, what is the effect of carbon chain length? As carbon chain length increase, okay, the hydrocarbon portion become more dominant. So which means the solubility of the alcohol will decrease. However, the boiling point of the compound is increases due to the high surface area. Okay, due to the high surface area. So semakin banyak carbon, okay, semakin rendah dia punya boiling point. Semakin rendah dia punya solubility. Okay. However, the boiling point will increase as well. Okay, due to the increasing of carbon atoms. In conclusion, you can say that hydrogen bonding controls the boiling point. Meanwhile, carbon chain length controls solubility trend. Now we move to the preparation of alcohols. Alcohols can be prepared in several ways. Okay, in this chapter, I will introduce you several reaction, which is 3 reaction that can prepare the alcohol compound. Which is the first one is the hydration of alkene, where you already learned in alkene chapter. The second one is the reduction of carbonyl, which is you can start the material from ketone structure or the aldehyde. And then the third one is the reduction of carboxylic acid, which is also of course from the carboxylic acid as a starting material. We look into the first preparation, which is the hydration of alkene. The hydration of alkene is reaction where the alkene react with water in the presence of any acids, concentrated acid, to form alcohol. In hydration, water is added across a double bond, so which means double bond will open up the bonding to adding hydrogen and OH, so which means this hydration alkene also known as addition reaction. An acid catalyst, for example, the sulfuric acid, is required to provide the hydrogen plus. The reaction follows the Markovnikov rule in the mechanism, Markovnikov rules, which mean the OH will attach to the most stable carbocation or most stable carbon, which is whenever you can compare the tertiary, secondary and primary carbon, tertiary carbon is more stable than secondary carbon and more stable than primary carbon. So which means primary carbon is the least stable of carbon. So for example, like this one, when propene react with water in the presence of phosphoric acid, it will produce 2-propanol. Okay, so since this hydration reaction follow the Markovnikov rule, the reaction will add the H and OH in the, let's say, I label C double bond C as carbon A and carbon B. So which means OH following the Markovnikov rule, it will attach to the most stable carbocation, which is, or the most stable carbon, which is at this reaction. Carbon B is secondary carbon, carbon A is primary carbon. So then OH will attach to the carbon B instead of carbon A, because carbon B is more stable than carbon A. That's how to get the major product for the reaction. If you try to solve this example, let's see, we try to solve the example together for the first reaction. Okay, so after you get the structure here, you focus on C double bond C, and then you may label the carbon double bond carbon as carbon A and carbon B. And then when it attached to water and phosphoric acid, it will do the addition at C double bond C with H and OH. So OH will attach to which carbon, A or B? So in order to make you easy, so you first of all you need to classify the carbon A and carbon B. Carbon A is primary carbon because attached to one carbon. Meanwhile, carbon B is secondary carbon because it attached the two carbons. Okay, so then the product that you will get is, you just draw back the structure without C double bond C. And then at carbon B, you just draw a new bonding and then attach with the OH. And this carbon B, meanwhile carbon A, draw another new bonding and then attach with the hydrogen. So then you will get the structure of this compound. How about the second reaction? For the second reaction, same as the first reaction, you just focus on the C double bond C, and then you label carbon A and carbon B. Then you classify the carbon. Carbon A is primary carbon, attached to one carbon. Meanwhile, carbon B is tertiary carbon, attached to 3 carbons. Then OH will attach to A or B. Of course B, because it gives more stable carbon. That's why the product for this reaction you will get like this one. So as I said, you just draw back the structure without the C double bond C. Double bond will change into single bond. Then at carbon B, you just draw one new bond and attach to the OH, and then carbon A, draw one new bond and attach to the hydrogen. So then you get the product. The last example here. The similar way, okay, focus on C double bond C, and then you can label as carbon A and carbon B. The next step, you classify the carbon. Carbon A is secondary carbon because attach 1 and 2 carbon. Carbon B is tertiary carbon because of what? Attached to 1, 2, 3 carbon. So then OH will attach to carbon B. So the product will get like this one. Draw back all the structure without C double bond C. Change C double bond C into single bond. Then at carbon B, you draw one new bond and attach with the OH, and carbon A, draw another new bond and attach at hydrogen. So then you can get the product. Also can be produced by the reduction of carbonyl compounds. In this reaction, aldehyde or ketone will be used as starting material, and then going through the reducing reaction to form the primary or secondary alcohol. For aldehyde, when it reduces, it will form the primary alcohol. Meanwhile, ketone will produce the secondary alcohol. So if you can see the ketone where the C double bond O not in the terminal, when it reduced to form the NaBH4 or ataupun LiAlH4, then C double bond O will change into COH. Okay, the carbon will attach to the hydroxyl group. Meanwhile, the aldehyde, C double bond O at the terminal of the molecular structure, go through the reduction reaction, then C double bond O change into COH, which is primary alcohol. Ketone, secondary alcohol. Okay, and then the third reaction that can produce the alcohol is the reduction of carboxylic acid. Carboxylic acid as starting material, it go through the reduction reaction using the LiAH4, and then followed by the concentrated acid. Then part of COOH will change into CH2OH, which is this will give the primary alcohol. Okay, C double bond OOH change into CH2OH will give the primary alcohol.